In this video, we are going to talk about Ethernet speed standards and physical media. We are going to talk about switch port configuration, and we are going to talk about detecting some error conditions that we can encounter on ports on our switch. When we talk about Ethernet standards, we are really talking about Ethernet speeds. How much data in an amount of time we can send out of this interface. What's the bandwidth on these interfaces? Generally speaking, in this day and age, there are 4 standards that are very, very widely used. Well, I should really say 3, but we can go with 4. It makes sense. The slowest one that we can still encounter today is 10 megabits per second. 10 megabits per second is standard IEEE 802.13, and it is the original Ethernet standard. So this is the original Ethernet speed. This is not very widely used today. This is why I said that we can say it's 4, but it makes sense saying it's only 3 because it's very, very seldom actually seen in modern day networks. This is also referred to as 10 base T standard. It's not the only standard that is in use or that existed. We had 10 base 2 and 10 base 5, but these were not based on hubs or switches. These were based on coax cables, thick and thin Ethernet, as they used to be called. Important characteristic about 10 megabit per second Ethernet, about 10 base T, is that it doesn't support full duplex by standard. Some vendor implementations, like for example Cisco, do support full duplex on Ethernet, but this is not to be expected. This is not something that has been standardized. The next one, and this one is widely used, is 100 megabits per second, or IEEE 802.3U. Now, this comes in several varieties, but the most commonly used ones are 100 base TX and 100 base FX. There are others, 100 base T4 if I'm not much mistaken, but it is very, very unlikely that you are ever going to encounter these in any equipment. I don't even know if Cisco supports anything other than those two that I mentioned. The difference between the TX and the FX version is that the TX is what we commonly refer to as the Ethernet cable, or the thing on the picture behind me. This is just a category 5 or category 6 cable that has 8 wires, and it uses the RJ type connector. FX, on the other hand, is based on fiber optics. These fiber optics can have different connectors. They are usually either LC, which are the smaller SFP kind of connector, or slightly larger ones called the SC connectors. So TX is copper and FX is fiber. In 100 megabit per second Ethernet, we do actually have the capability to negotiate half duplex or full duplex transmission. Now, I mentioned half duplex and full duplex twice so far. Let me explain it a little bit. So, what happens if on a network segment we have only 2 devices that are connected? And they are directly connected, so there is nothing in between, just host A directly connected to host B. Now, one of these could be just a host, and the other one could be, for example, a switch, or it could be a router, or any device. It doesn't matter what these devices actually are, but they are directly connected, so there is nothing else between them. Now, if we have only 2 hosts connected, and we are using twisted pair connections, which means that we are using 4 wires to interconnect, which means we are using 2 pairs of wires. So we have really just this kind of thing set up. Now, we can say that this pair of wires here is connected to the transmit side of the circuit. This one is connected to the receiving side, and we have the exact reversal of roles on this pair here. So let's call this one a green pair, and let's call this one a blue pair of wires. So traffic sent by A to B is going to go over the blue pair, and traffic sent from B to A is going to be sent over the green pair of wires. Really, is there a need to detect any collisions here? Can there be a third device on this network segment that can transmit? Well, the answer is simply no. So running this in half duplex mode, in other words, speaking only one at a time, makes absolutely no sense. And this was recognized relatively early in the standardization phase of Ethernet when when the designers of Ethernet were designing fast Ethernet, and they recognized that this particular solution here is a solution that can be used to our advantage to implement a full duplex communication. Full duplex communication means that both A and B can speak at the same time without fear of any collisions. And this is something that fast Ethernet tries to negotiate. It's very, very important because instead of having 100 megabits per second overall, we actually have 100 megabits in each direction between A and B, which means that effectively we have 200 megabits per second capacity between A and B. Very, very important thing. Now, let's go back to other standards that we have. And here we have the next one is 1 gigabit per second Ethernet, or IEEE standard 802.3Z or Z. This comes in really wide variety of standards. Now, I'm going to have to remove myself from here so that you can see all the standards that we have here. So gigabit per second comes in 1000 base T, 1000 base CX, 1000 based SX, 1000 based LX or LH, and 1000 based ZX. Now, 1000 base T, as you might guess, is actually a copper based. It uses category 6 cabling. 1000 base CX, to be honest, I can't really remember which one that is. It's not very, very widely used. We have 1000 based SX, which is something that we call the multimode fiber that uses 62.5 nanometers fiber connection. Then we have 1000 based LX or LH, which uses the single mode fiber, which is, I believe, 9 microns diameter, and it's used for very, very long distances. I believe that the distance there is 10 kilometers, which is about 7 miles or so. I do apologize, I'm metric. And then we have 1000 based ZX, which is for extreme high distances. This is when we go to 40 kilometers, and in some cases we can go even further with ZX if we have really, really strong lasers in our transmitters. Personally, I was involved in a project where we have been shooting this to a distance of about 100 miles, so about 150, 160 kilometers with specialized lasers. 10 gigabits per second 802.3AU comes in even wider variety of standards. We have 10G base SR, SW, we have 10G base LR or LW, we have 10G base ER, EW, 10G base LX4, LW, and so on and so on and so on and so on. The real point about the 10 gigabit per second Ethernet is that it is full duplex. There is no half duplex there. Also, both gigabit Ethernet and the 10 gigabit Ethernet utilize 8 wires, 4 pairs in a cable. So the cable that you see above me here would be okay for gigabit Ethernet and for the copper standard for 10 gigabits per second, but only if all wires have actually been connected. And this is very important, especially if you are installing 10 gigabit Ethernet or gigabit Ethernet in slightly older wiring closet where the installers, the original field engineers, field technicians, took some shortcuts to just make fast Ethernet work, which needs only 4 wires. But for gigabit Ethernet, you need to use all 8 wires. So be careful about that. Also, very common thing is that if you wanted to connect two hosts directly, let's say two PCs or switch to switch or router to router, for fast Ethernet and 10 meg per second Ethernet, we used crossover cables where we would actually cross the transmit to the receive side on the other side of the connection, instead of relying on these connections being inverted on the ports. I'm going to talk about that in a second. So crossover cables were just fine for fast Ethernet, but they no longer work for gigabit Ethernet or 10 gig Ethernet if you are using copper connections there. For fiber, none of this applies. So going to the next topic here, and we're going to talk about the Ethernet port configuration. When we are configuring ports on the switches, we can configure multiple things. Now, the first thing that I'm going to talk about is actually the last thing here on the slide. I'm going to talk about how do we specify which port we want to configure. Let me show you what I mean here. Let's say that we have a relatively simple desktop switch from Cisco. What I mean by relatively simple is the switch that is in a fixed format, that doesn't have multiple line cards. A good example of this kind of switch is, for example, 3560 from Cisco. So this switch here is just a fixed format, which means that it has any number of ports. It depends on the model, but usually they have 24 or 48 ports. But let's say that we have 24 ports. If we want to configure port number 1 here, this port would actually be either fast Ethernet or gigabit Ethernet 0/1. Now, this 0 here refers to the module, the interface module that exists on the device. In case of fixed configuration devices, this applies to switches and routers. The first module, the one that is actually built into the device, is always going to be 0. It used to be in very long days that we didn't have that on Cisco devices, that this device would just be fast Ethernet 1 or fast Ethernet 2 or fast Ethernet 3. But these days, almost all devices coming out from Cisco have this kind of numbering scheme. So the first number here refers to the module, and this one here refers to the port on the module itself. But sometimes things are not as straightforward as this. Sometimes we have switches that are a little bit more complicated. Let's take, for example, a 6500 switch into account. Now, 6500 switch can have any number of line cards installed. Line cards are really just cards that carry a lot of slots. A lot of ports. Now, these line cards here have their own module identifier. So let's say that this is module 0, this one here is module 1, this one is module 2, and so on. The numbering may or may not start from 0. Now, some line cards actually have ability to install additional sub-modules there. They're just kind of carrier cards for other cards. In this case, if you wanted to configure port number 1 on module number 0 on sub-module 1, the actual port number there would be, let's say, fast Ethernet. We're going to have slot, this is actually slot 0/1/0, if this was here port number 0. So the naming convention here for interfaces becomes a little bit more involved. It depends on the switch type, it depends on the device type, what slot 0 is, what module 0 is, what module 1 is. So this is something that you simply have to learn for the device that you are actually working on. In almost all examples that I'm doing here, my switch that I'm using is actually Catalyst 3560. So it's a fixed configuration switch here. So all my interfaces actually have the naming convention type module, and it's always going to be 0 because this is a fixed configuration switch. And then finally, I have the interface number here, 1, 2, 3, and so on. If I take a look at fast Ethernet 0/1 and gigabit 0/1, I can see that the actual number here that we have, 1 and 0, 1, kind of overlaps. This is perfectly okay. This is not referring to the actual same interface. These are two completely different interfaces because the type of the interface here is also significant. So this is the first interface on module 0 of type fast Ethernet. This is the first interface on module 0 of type gigabit Ethernet. Cisco does it this way, some other vendors do it slightly differently. With some other vendors, you cannot have this overlapping thing. But this is perfectly okay. On Cisco, you can actually have these overlaps. So when we are configuring ports and when we have selected which port we want to configure with our interface type slot slash module slash port or just type interface type slot slash port, then we can configure certain characteristics of the interface. By default, on all modern Cisco switches, the port is automatically configured by default to be in a no shutdown state. It's configured to be in auto negotiation mode. That means it will negotiate speed in duplex with the other side. This is very, very important concept here. If you want to have a reliable connectivity between two hosts in your network, you need to make sure that the speed matches, that the duplex settings also match. You can do this in two ways. One is manually set the configuration on both sides, or set it to be negotiating on both sides. If you don't negotiate from both sides, you can have rather unpredictable result. And this is something that I'm going to talk about in just a minute. So let me show you what I mean here. If I go back to my switch here and I take a look at the configuration of Fast Ethernet 01, I can see that I have some additional configuration there. This is just to make the port come up faster, for spanning tree to move into forwarding state a little bit faster. So it doesn't have any significance to what I'm talking about now. I can see that this is a default configuration on the port other than that. So let's take a look at, for example, Fast Ethernet 05. This is the default configuration, except that I have actually shut it down. So really no differences there. If I take a look at what's the situation on Fast Ethernet 01, I can see here that this port is operating in a full duplex mode at 100 megabits per second speed, and I can see that the media type is 100 base TX. So this is a 100 megabit port operating at 10 megabits per second. Now, device that is connected on the other side here is my router R1. This is the configuration on the other side. So I can see here that my duplex is set to auto, that my speed is set to automatic. Let me go about and change one of these parameters. So what I'm going to do here is I'm going to say speed 10 megabits per second. What's going to happen now is when I do shutdown and I do no shut, and when interface comes back up, if I go back to my Cat1, what I'm going to see here is that port is operating in 10 megabits per second. We also appear to have negotiated full duplex here. And if I do show interface Fast Ethernet 00 on the other side, it looks like it negotiated full duplex. I'm operating at 10 megabits per second, which is okay. 10 megabits per second is fast enough for certain things. But the important thing is that if the speed doesn't match, your interface won't come up. The other side is negotiating, so the interface actually came up. When configuring ports manually, there are really 4 things that we can configure. Well, 3 plus 1 that I'm going to just mention. It's not really that important. It happens only in rare circumstances. We can configure the speed of the port, and depending on the interface that you have, this is usually going to be either 10 megabits per second, 100 megabits per second, or 1000 megabits per second, really 1 gigabit per second. We can set the duplex settings. This can be either automatic duplex, or it can be half duplex, or it can be full duplex. Another thing that we can set on most modern switches is, do we want to have the port operate in MDI or MDI-X configuration? MDI stands for Media Dependent Interface. What we mean by this is, if we go back to our first drawing here on the whiteboard, you can see here that one side, our green pair on switch B, is operating in transmit mode, and the blue ones are operating in receive mode. What if we connected another switch to this switch B? Let's examine that again on the whiteboard. So what I'm going to do here is, I'm just going to add a new page, and I'm going to have, let's say, switch 1 connected to switch 2. Now, if we assume that the left-hand side of the switch is transmit, and the right-hand side is receive, this is what we are going to end up with. We are going to have a transmit connecting to transmit and a receive connecting to receive. In other words, we are not going to get a lot of communication there. This used to be solved by using a crossover cable. A cable that is actually going to make a cross here so that we invert receive and transmit in the cable itself. That is because switches have ports that operate in MDI-X mode. Hosts, on the other hand, like routers or your PCs or whatever devices we have, operate in MDI mode. MDI is designed to connect to MDI-X. Now, using crossover cables doesn't always work, because for gigabit speeds, not a good thing. This is why in most modern switches, the ports can actually dynamically determine whether they want to operate in the transmit mode or they want to operate in the receive mode. So this is something that you can actually configure on the interface, and the command that is MDI-X auto. Now, if you configure MDI-X auto, the switch is automatically going to determine whether to, it's automatically going to determine should the ports be in the receive or transmit mode, the different pins on the port. You can actually turn this configuration off. So here, now I have disabled this functionality. So now if I wanted to connect switch to switch, I would actually have to use a crossover cable. For fast Ethernet and regular Ethernet, 10 megabits per second, this is no big deal. But if I wanted to use gigabit Ethernet, I would need to create a special crossover cable. It doesn't look the same, and the wiring is not the same as with those other crossover cables. The last thing that I wanted to mention in this segment is the concept of configuring the media type. Now, there are some devices that have one port that can be connected to either a fiber connection or to a copper connection using RJ45 connector. An example device here is, say, a 3900 router or 3800 router, which has one port that has both the copper connection and the SFP. And on the interface, you can choose which one of these connections you want to use. You can't use them at the same time, so you have to make a decision. Which one do you actually care about? On my equipment pod here, I actually have a device like that. This is my R2. It has gigabit Ethernet 00 that has a dual media port. Now, in my case, both copper and fiber are connected to Catalyst 1. They're not connected to the same port on Cat 1, so we should be able to observe the result of setting the media type. So now if I go to Cat 1 and if I do show CDP neighbors, I can see that R2 is connected to fast Ethernet 02. Let me go to R2 here and change the media type from RJ45 to SFP. What's going to happen here, and let's go back to Cat1, I can see that Fast Ethernet 02 went down and Gigabit 02 came up. Now, it's just pure coincidence that it is actually 02 in both cases, but these are two completely different ports, as I explained earlier. So if I do show CDP neighbor now, I can see that R2 is visible on Gigabit 02 instead of Fast Ethernet 02, where it was visible just before. Let's talk a bit about detecting error conditions on the switch. Switch has the capability to detect certain types of errors and automatically disable the port on which these errors have been detected. This process is called the error disable process. It is turned on by default and it can detect a large number of error conditions. You can see which conditions can be recovered, can be protected using this functionality using the error disable detect cause command. Let me show you. So going to my terminal, I'm going to say show error disable detect here, and I can see that my error disable functionality is enabled for large number of features. I can see it enabled here for ARP inspection, the BPDU guard, the channel misconfiguration, that this refers to Ether channel configuration. It can detect invalid GBICs, it can detect the problems with the inline power, and so on and so on and so on. So this error disable process is actually turned on by default. If a port detects, if a switch detects a problem on a port, it is going to shut this port down. Except it's not going to go into the admin shutdown mode. So if you do show interface, it's not going to show down, down, or administratively down, down. It is actually going to show down, down, and then in parentheses, it's going to say error disabled. By default, the port will not automatically recover from this condition. Even if you unplug whatever was plugged in on the other side and plug it back in, the port will not recover. The only way to recover from this condition is to manually shut down the port and then do the no shutdown. Sometimes this is desirable behavior, and sometimes you actually want to have switch attempt to automatically recover from the error condition, and this can actually be changed. It can be changed on the switch using the error disable recovery cause command, and here you can specify for which causes you want the switch to attempt to automatically recover from. You can specify either all, or you can specify any of the causes that will cause the switch to disable a port. Now, when error disable recovery is enabled, it is going to operate at a fixed interval. The default interval being 300 seconds. But you can change it to any value between 30 to 86,400 seconds. The last thing that I want to talk about today is a very common error condition in the networks, which is called the duplex mismatch. This is the situation when one side of the connection is configured for full duplex and the other side is configured for half duplex. Now, this can have severe impact on the network performance. It is going to get worse if you have large amounts of traffic going through your network, and it can drop the transmission rates from 100 megabits per second down to about 10 megabits per second. And this is a situation that may be rather difficult to figure out for novice engineers. If you are using slightly older versions of the iOS, in some newer versions of the iOS, routers will tell you if they are noticing that you may have problems with duplex mismatch, but they're not necessarily going to tell you that. Also, CDP can be your friend in this situation, because the CDP, when you have two switches connected, they're going to tell you that you may have a CDP that you have a duplex mismatch. But if you don't use CDP, or if you are using say non-Cisco devices, or you are connecting a Cisco device to say a PC, this situation may be a little bit tricky to discover. You actually have to use different methods to find out that you are dealing with the duplex mismatch. Your symptom number one in production network would be a severe degradation in the traffic. The next thing is you want to go ahead and take a look at the output of show interface command. Now, while I was doing this module here, I actually had R1 and R2 send a large number of pings to each other. Now, R1 is connected to switch 1 and is connected to the port with a misconfigured duplex. So